without further ado, let's get started. So thank you everyone for joining the next session of our CRP Professional Development Series. This webinar will be about navigating Australian airspace. I'm your host and moderator today. Hover UAV has listened. Your favorite presenter is now in charge. Jackie's laughing away in the background. So to do this, we have assembled a crack team. I will start talking first about who we are. So Hover UAV is an RPA regulatory and services organisation based in Australia but operating globally. We're experts in providing approval and consultancy-based support, developing training and support materials and delivery products, and providing operational support such as compliance and CRP services, as well as developing some new technologies like the Soramate platform and our Skycom's Comms in a Box product. Now, I have assembled a crack team to assist me in talking through the Australian airspace today. So I've brought in Jared, who is a commercial pilot with hundreds of hours of experience ferreting passengers all around Australia. He's also Hover UAV's own CRP and has operational experience both at the management level and in conducting BVLOS and other complex operations in the field. From Airservices, we are very pleased to be joined by Sasha Nikolic. He is a senior leader in the Airservices team, focusing on strategy and operational delivery. He is currently working on the development of Australia's Uncrewed Traffic Management ecosystem. And our good friends at AVCRM have also loaned us their director, Chris Clark, who is a passionate aviator with a history in aerobatic flying, commercial piloting, and one of the co-founders of AVCRM. He's here today to share with us the capabilities of the platform when planning and conducting operations in a variety of airspace. So without further ado, I'm going to hand over to Jared now, who's going to start talking us through airspace tools.
Hi guys, thanks Don. Thanks for the introduction. Well, everybody be kind to me. This is my first webinar, so just be gentle. I am new to this. So today I'm just going to run through with you for tools we can use for flight planning. We've observed I've observed over the years, and I guess we all have, sometimes chief remote pilots and pilots in general get overwhelmed with where to get the information they need to plan a flight. Now, VLOS flights, there's usually not much planning that's involved. However, as we progress and we get into more advanced operations, your EV losses and your BV losses, flight planning becomes a major component of the operation. So you need to be able to get the tools together, have an understanding of your airspace, and know where you're operating. There's a lot more involved at that point. So I've put together some processes that might help you identify how to get the information, what tools you can use, where to go to be able to understand the information you can get. So we'll start with digital applications. Everything is online nowadays. That's how we're going to operate. You know, unlikely that you're going to have a paper chart sitting on your desk to be able to do anything. So we have the CASA verified drone safety apps. So we recommend to only use CASA-approved drone safety apps because they've actually been, you know, confirmed by CASA to be able to tick the boxes for legislation and tick all the requirements for compliancy. There's currently 11 apps that are approved, available on the CASA website, where you can get information on what is approved. The QR code there will take you to that particular website. Using the verified app ensures that the software meets the requirements of the regulator. There's no point using some other third-party software that isn't actually ticking the boxes to what the information you're trying to get. An example of such software, and we have Chris with us today, is AVCRM. So on the screen there, you can see I've just done a basic sort of outtake of what an application can give you. So this AVCRM tool here in particular, I've just got it up on the sort of airspace calculator page, but we can put in where we're operating, and it actually gives me a good overview of what airspace I have to work with. Over on the right-hand side here, we can break down, and it gives me the particular airspace, frequencies I need to use. It tells me the particular type of airspace, and any hazards associated with the area. So very handy tools to have. AVCRM is one of the ones that we use, but there's, yeah, as I said, there's 10 others to choose from. But this is the one I'm most familiar with. So yeah, very handy tool indeed. So basically that also includes digital charts building if you like. But the other option you do have are aeronautical charts available from Airservices Australia. So we are very lucky in Australia. We do have access to these charts free of charge. Other countries charge you for all of this information. However, we can go to the Airservices page, the particular website and get access to the charts. So the most useful charts for RPAS operations are your VNC, which is your visual navigation chart, your VTC, your visual terminal chart, your en route chart, your WAC, World Aeronautical Chart, more for topography information, and then you got your aerodrome and approach charts, your DAP charts. So they just give you a little bit of understanding about maybe approach procedures into airports around you. So charts generally will highlight all the elements required when you're planning a flight, including airspace types, VHF frequencies, aerodrome and HLS information, and other more advanced information such as lowest safe altitudes for grid and route lowest safes, and things that, as you get a bit more advanced and maybe operate at high altitudes, are considerations you need to factor in. The departure and approach charts highlight information for instrument approaches into aerodromes, which may be important even though you're not normally operating within 3 nautical miles of an airport. The instrument approach procedures may run over the top of where you're operating. They could be out to 15 miles from where the actual aerodrome is itself. So a lot of information is there in those DAPs. It gives you a high level of situational awareness, particularly in those approaches. You can have an understanding of how that aircraft is going to approach the airport to determine if that's going to affect your ALPAS operation. And as I said, best of all, this is all readily available on the Airservices website. So the QR code will take you to the AIP page there. We can get access to the charts in PDF format and any other charts there. Another important tool is the ERSA, the En route Supplement Australia. It's an essential document for planning, and not only does it include specific aerodrome data, as what most of us pick it up for, but it also has other information in the back of it relevant to restricted danger and military operating areas, also known as special use airspaces, which I'll talk about a little bit later today. It also includes information on how to decode NOTAM and weather, which a lot of us get caught on. And it also has some other information, has special procedures and flight enabling advisors for crewed traffic. So that might be another tool that gives you situational awareness to understand what is happening around you in the airspace where you intend to operate your RPA. So once again, that is also available from the Airservices website. Next, we have the NAIPS system. So NAIPS is the National Aeronautical Information Processing System. It can sometimes be accessed through third-party applications, but ultimately it is using NAIPS as the baseline to get that information. That's your go-to for NOTAM, aeronautical weather forecasts and reports, first and last light details, and all those type of information. So very handy to have access to, and it's very easy to use. There is guidance for how to operate it. From Airservices themselves, you can actually get guidance material to how to work NAIPS. When you first go in, it can be a little bit confronting, but once you learn how to navigate through the system, there's a lot of information you can get from it. So moving on next into height versus altitude. So this is another thing that we see people get confused of. And as we move into more advanced operations, we are starting to move between height and AMSL, and they are two different things. So there's sometimes confusion understanding the difference between height and altitude. They're commonly words that are interchanged, however, they are actually two different things. So AMSL is above mean sea level, and what it means is it's reference for the RPA altitude above the mean sea level, where AGL, or above ground level, is reference to the RPA's height above the ground below the aircraft. So it's actually above a ground, not above the water as such. Crewed aviation generally use AMSL as a standard, as the drone industry has adopted AGL as a standard. So there is a little bit of discrepancy there. As the industry moves towards BBLOS, however, AMSL is becoming increasingly adopted as a reference for RPA altitudes in this case. So when integrating with crewed aviation, it's more effective if both crewed and RPAS operations are on the same channel. We want to be talking the same heights or altitudes. We can't be mixing and matching the methodologies as when we communicate, and normally it's at the last minute because there may be a deconfliction requirement, and all of a sudden you're talking in meters, the pilot's expecting that in feet, and you're talking AGL and they're talking AMSL. So it can get very confusing very quickly and could lead to safety concerns. That's another thing. AMSL is usually expressed in feet. So in Australia, we use feet for altitude in the crewed world, and in the unmanned world, we seem to use AGL and meters. So we've got two discrepancies there already. One is the datum of how we're measuring our height or altitudes, and the other is how are we actually outlaying that information. So it is quite confusing, can get a little bit confusing, but it is something you need to be aware of. So AGL versus mean sea level. So most manufacturers use the launch location as the primary reference for their flight parameters. So measuring the height from the location. So when your DJI drone takes off, it's measuring where it's taking off from, and that's its 0 point. It takes off to 10 meters. It thinks it's 10 meters, no matter what ground you fly over. So as you move over different terrains, it's still basing it on where you took off from. And that's the actual height of the aircraft. The whole system works around that. Even if your system can display AMSL, it's still using AGL as its fundamental baseline to control the drone itself. So AMSL calculation method. So more advanced systems like the enterprise systems for DJI, they can actually display AMSL, and they're using GNSS data to get that information to you. Underlying all that, though, it is still using AGL and that initial launch location for the functionality of the aircraft itself. Now, GNSS altitude data accuracy will vary depending on location and where you are, and depending on GNSS coverage and other variables. It's usually good for plus or minus 10 meters. However, I've sent it out by 80 meters depending on satellite coverage. The AMSL displays on your controller, it's more for compliance side and information to the remote pilot than it is actually how the system is operating. So you will have to have an understanding of how to do a basic conversion between both. Now, I work with a lot of clients who work in the mining sector, and this is secondhand nature to them because they know their elevations and know their AMSLs, but for the rest of us, it may not be the case. So there's three things or one extra thing you need to know when you're trying to work out your height. So to do a conversion, you basically need to know your elevation, where you're operating from. Then it's simple math. So to work out your AMSL, it'll be your AGL plus your elevation gives you AMSL height, give or take. It's all give or take. We're not going to have exactly precise heights here, but it's going to be a lot better than just talking in AGL terms. So on the screen there's just those basic conversions. Once again, something you can find online. Have an understanding of it though if you start to move into more complex operations where AMSL is needed, as that'll become your go-to. Another downside to the systems, from what I've witnessed with DJI, you can't have a hybrid system in the settings either. You can't have a meters distance and a feet height. It's all going to be in metric or it's all going to be in imperial. So there is a bit of a mix up there. So once you convert your controller into feet under the settings, you're also going to get your distances in miles. So it is one downside to it. So just factor that in as well. So there's also another thing we need to factor in, that's the effects of pressure. So in crewed aircraft, we can actually change the subscale on the altimeter to the local area barometric pressure, as AMSL has factors in there that include barometric pressure for the area and also temperature that will give you the correct height. We don't have this option with drones. We're relying on that GNSS data that's giving us that information, and we expect that to be updating as we fly. Now, if there was an issue with it not updating, there's a chance what's displayed on your screen is actually different to the height of the actual drone because of the pressure changes. So without going too deep into pressure and density altitude, otherwise we're moving right into manned aviation, the basic rule is from high to low, look out below. So what that means is if you're flying from a high pressure area to a low pressure area, you just got to be certain that the RPA may likely be lower than it is actually displayed on your display. So just be wary of that if the system doesn't keep up with updating its height in 3 dimensions. All right, moving back towards other important elements, NOTAM. So NOTAMs are important aspects for us. It advises all hazards for airspace users. So not only drone operations, but also manned aviation. So and that may include UPHAS operations above 400 feet, aerodrome changes, restricted area and military operating airspace activations, fireworks, air displays. There's a lot of information you can get from NOTAM. It is available in the NAPE system or within third-party apps. You can get access. Once again, the NAPE system is the underlying information there. So to read NOTAM information, a lot of people get confused with how to interpret it. You can get information from the AIP, the Aeronautical Publication Australia, the NAPE's user guide, the NOTAM data quality requirements documents, and there's also the big one, English decoding tools, plain English. So you can actually get NOTAM information, dump it into one of these tools and it'll spit it out to you in plain English. So it's very, very handy to have. Another part of that is aviation weather. So yet another thing we can access in NAIPS in similar formats to NOTAM. You do know how to need to read it, but it should be sourced ultimately from the BOM, the Bureau of Meteorology, and that's where NAIPS gets its information from as well. And it may also be available in your drone safety apps. So your main considerations for RPAS operations, you're looking at TAFs, so your terminal area forecast, you're looking at your GAFs, your graphic area forecasts, and you're looking at your GPWP, that's your grid point winds. So have an understanding of winds and temperatures. So once again, to read the weather, people get a little bit muddled in it. It is hard to understand, but you can go to the Aeronautical Publication Australia once again for guidance on that, and that is available through the Airservices website. You've got the NAIPS user guide once again, and a really good place to go for the information on reading aeronautical weather is the Bureau of Meteorology website for the knowledge centre they have on there. It is amazing the information they have on the Bureau of Meteorology, their knowledge centre. You can download a whole information card just on a TAF and it'll break it all down for you so you can read it line by line to have a really clear understanding of what it's trying to tell you. And lastly, you've also got online plain English tools as well. You can put the information into it and convert it. Some of the software will even do that for you nowadays. Software such as Oz Runways or AvPlan, which is more of a crewed world EFB, it'll give you the information you need. Yeah, Paul, Windy's okay, but it's not an approved source of information. You really want to stick to your approved sources of information, particularly when you start operating more complex operations. So just as a summary there for airspace planning and tools, use only CASA-approved safety apps. They have been approved by CASA for a reason. They're ticking all the boxes for the regulatory side of things. Airservices Australia provides free access to all your aeronautical charts and a lot of documentation there. So definitely have a look over that website, see if there's anything that you can use. That includes the URSA. URSA is very important. It contains information relevant to RPAS operations, not limited to aerodrome procedures. It'll talk about, and I'll talk about a bit more later, restricted areas and danger areas, etc. AMSL is being increasingly used in the industry. Ensure you understand the system and how it affects the functionality, particularly your return to home operations. Have an understanding of what AMSL is, how it fits into your operation. AMSL readings can be inaccurate based on known barometric changes. Always allow for this error during your operations. So once you get to BVLS level, there are buffers there that would factor that in, but below that, if you are operating AMSL, just be careful. If that GNSS data is not keeping up, your actual altitude may vary to what you're seeing on the screen. NAIPS is the primary source of NOTAM and weather data that you go to. Ultimately, that's aeronautical approved weather, so it's the weather you're going to want. And lastly, the Bureau of Meteorology provides detailed information to assist in interpreting weather details. I highly recommend that if you have trouble interpreting TAFs, definitely look at that Bureau of Meteorology Knowledge Centre. It'll really make things easier for you. And that is it for planning. So thank you. We'll pass back over to Dylan now, and he'll
Yeah, thank you very much for that, Jared. So we are going to put Chris from AVCRM into the hot seat now, and we do have some very big questions for him. So we're going to be focusing on, can drones fly near airports? How do I tell what each class of airspace is and means? How do I choose the right radio frequency for an area? And what tips you may have as an experienced aviator around making radio broadcasts. So Chris, I'll hand the presentation over to yourself now.
Thanks, Dylan and Jared. First of all, I'd just like to say thanks to the Hover team for putting this on and the invite. Yeah, it takes a lot of effort to organise these things, so I appreciate that. So I guess my presentation, or part of this, will centre around initially operations near uncontrolled aerodromes. So I'll share my screen. So as Jared mentioned, there's many tools that you can use to assess, whether your operation is going to be conducted in particular types of airspace, whether it be a CASA verified application, or as archaic as maybe even pulling out a chart, which I'm not going to do today because that wouldn't be a very exciting presentation. But one of the key considerations I've always had around when you're operating in and around airspace as an RPAS operator is that those PTC charts are all centered around traveling a larger distance in a short period of time, like a crewed aircraft, helicopter, or fixed wing aircraft. And the RPAS environment is usually a smaller area, and we're spending more time in that particular area. So when you're making those plans, it's important to make sure that the ops area that you've planned for actually falls entirely in or outside of the airspace that you're considering. And when you're using an application to do that, it's important to understand that it's not just taking an average point of your ops area or a single point on the ground, because your ops area may cross over into other pieces of airspace or no-fly zones. And so that's partly in my presentation. We'll talk about how AVCRM handles that. But if we have a look on my screen here, we can see my operations area over the power station here. It is in a couple of overlapping pieces of airspace. And when we first have a look at this, it can be a little bit daunting to decode what's going on. So a way that we can do that is we can simply click on the area, and it'll bring up a information window that tells you what this piece of airspace is, or what it relates to, in this case, the no-fly zone of Shellharbour Airport. And also, and if it's controlled airspace or uncontrolled airspace, that information will appear. But it also gives you the MOS references to, so that you're not correlating, okay, what can I do in this piece of airspace in separate documents, so we can sort of see what those rules apply in that piece of airspace. Now, as Jared mentioned, we've got this filtered area here. A good way to start with this, to sort of make it a little bit less daunting initially, is to actually turn off all of the filters and start with a bare map. So as I start to add the layers, I start to see what each of the threats or airspaces that I might need to consider are. And so we start to build up that situational awareness and understand what the rules are around flying close to aerodromes. So on this one, we can see the no-fly zone, which is essentially a race course pattern around the surveyed points, the threshold points of the runway, extending out to the limitation. And so that's why you'll see this odd kind of shape. We've got two overlapping areas. We've actually got one for the cross runway here at Shellharbour and one for the north-south runway, and that's why we get this unusual shape. And in the red zone, we can see the departure and approach areas for the runways, and these obviously are important because that's where you're going to see the aircraft coming closest to you or closest to the ground as they take off and land from the airfield. So as I start to build up the picture, I can start to see more and more detail on those items and those threats. As we build it up, we'll see more and more. So for a standard VLOS operation where we're just operating in that no-fly zone, we can see that the rules will require us to land if there's a relevant event. We also have the ability to turn on this indoor tethered and approval toggle here. And so if you are operating under a CASA approval to operate it during a relevant event or on a tether, then it will redraw the diagrams, and that information window will change as well to help decode that situation. So an important part of it now is now that we've got a big picture situational awareness of what's going on as far as airspace goes, let's break it down into the actual ops area itself. So down the right-hand side here, we can see each ops area, and you could have multiple operations areas in your job, and it will break down that specific area into a bunch of information tabs here, telling you about this particular area. So one of the questions here is, how do I choose the right radio frequency? Well, what airspace is my actual operation area in? This is where we go to do that, is to come to each ops area, and then we can just simply add, this is in non-controlled airspace or class G, everything other than controlled airspace. And so we'll add that to the job. And then further to that, we've got a bunch of tabs down here that are going to break it down and show you what the relevant frequencies are going to be. But sometimes this can be, full of lots of different frequencies, and now we've got to make a decision on which one we're going to put in there. So I always like to come to the airport tab. And at the top, it's showing us that the biggest and most important sort of piece of airspace or no-fly zone relative to this ops area is actually the Shellharbour Airport. And so you'll see it changes the color of those in the list. And from there, I can just add the frequencies relevant to that, aerodrome. So I can just simply add the CTAF, Common Traffic Advisory frequency, and then the area frequency that sits above it of Sydney Centre. Typically speaking, most of your radios are going to have one or potentially a dual watch function. And so you've got those two frequencies. They're now added to your job. And when you take this out into the field, in the field app or online, it's only going to show you those required frequencies. So that's a little bit about sort of planning around a non-controlled aerodrome, selecting the right frequency. How can we determine what the airspace that I'm flying in is? And then the last question that I had was, do you have any tips for making radio broadcasts? So one of the biggest issues, I think, between crewed and uncrewed operators is that we all talk on the same language. So commonly I would interact with uncrewed aircraft and they'd be telling me a physical location on the ground. And that doesn't mean a lot often to a crewed pilot because we're looking at charts and we're referencing, an airport or an inbound point or a particular published route. And so one of the important things that I always say is that it's important to give your position in altitude, so feet above sea level, and a position relative a known point. So in this case, we might say that we're 2.5 nautical miles northeast of Shellharbour Airport. When we're making our radio calls, it's always important to be concise and clear. And as a general rule of thumb, we address the station, so in this case, traffic Shellharbour, and then we want to say who we are, where we are, and what our intentions are. So we're an RPAS aircraft operating 2.5 nautical miles northeast, conducting a survey operation not above 400 feet, for example. Keep it clear, keep it concise, and if all else fails, just remember it's a conversation between two people. Plain English is always your best bet. So I think that pretty much covers my few questions, and so I'll hand it back to Jared.
Thanks, Chris. Yeah, couldn't agree more. Plain English. Ultimately, that's what I tell everybody as well. If you get mixed up what you meant to say in aviation jargon, speak plain English. You're better off saying something rather than nothing and watching your drone head towards another aircraft because you were too reluctant to actually use the radio. So thanks, Chris. All right, guys, now we're going to move into special use airspace. So Chris spoke of airspaces. Some of them may involve restricted areas or military operating areas. So the restricted area military operating areas are depicted on aeronautical charts, in drone safety apps, or even on electronic flight bags if you're looking at something like Oz Runways or plans. So very easy to identify. They're normally circled by a red line, and they're designated a certain area. They have like an R figure and Romeo 365 or Romeo 412 Alpha or whatever the case may be. Much is the same with the military operating area. So the military operating area is a fairly new thing we've had brought into Australia. It's only been operational since November last year. The military operating area is much the same as an RA in Australia. So you do need to have approval to operate in an active MOA or an active RA. Now, most of these areas are activated through NOTAM. So you're relying on your NOTAM service now to have an understanding of if the airspace is active or not. So first of all, you will identify your actual location on a chart or however the case may be, and then you're going to go in and see if it's going to be becoming active in the NAIPS system. So to the right there, you can see a little extract I've taken. Now this is from NAIPS on my phone. I've actually got an app called NAIPS, and it makes it very easy. As you can see, it's color coded. Green means good to go. Red means it's active at the current time that I intend to look. And orange means it's up and coming active. So you will need to look at NAIPS or a third-party app to actually have an understanding of what's happening in that area. And then if it is active when you want to operate, you will need an approval to operate within that area. Now, usually in that regard, it's a lot easier to get that approval if you're operating under a REOC. We have noted over the time. The military usually don't work with excluded category as much. So if you're operating under the REOC, usually they just ask for some information and they'll go through the motions to get you that approval. So now allow sufficient time to get that approval. Don't just expect to get approval on the same day. So the MOA, yeah, I just saw that that note there. We had the same issue. I was looking it only up the other day, and it does say it is depicted as a danger area. However, they are active on and off. So the rule still was you need approval to fly in them. So I am seeking more information on that one. So yeah, there is a bit of a discrepancy there, and Dylan and I only discussed it the other day. It does say it's a danger area, but there is still an approval to need to actually operate in them. So approvals in these areas are dictated to by the airspace manager. So you have to go to the relevant manager who's running that airspace. That may be Williamtown, it may be any other of the RAAF, or it may be someone not military. There are some restricted areas in Australia that might be the CISIRO or something of the like. So now that approval process is dictated to by that individual person. So you'd have to go through their procedures to get that approval. Now, where do you get that information? Who do you contact? You go to is NAIPS. So in the back end of NAIPS, you can go, IRSA, apologies, IRSA. So in the back end of IRSA, you can actually find that restricted area or whatever the area may be, look it up, and you can get information from there to who to contact to get information regarding the approval process in that particular airspace. So that area, it will have the type of operation you're expecting, how it's activated, who's running it, the area, and sometimes the altitudes of what it's operated up to. So that'll sort of vary depending on the location. So in the back of the IRSA, you have your danger areas, you have your restricted areas, and you have your MOAs, your military operating areas, all with information where you can contact the appropriate person. The other place you may find information is within the actual aerodrome section. So within the aerodrome section, under the particular aerodrome, and in this case, I've got Williamtown up on the screen. Williamtown may even manage airspace miles from where that airport is. However, it's the same people still managing the airspace. So you can have a look under the Williamtown listing if you identify that restricted airspace is associated with them. And you can see in here, all RPAS requests are to be sent via email to Williamtown Defence. Send them an email, they'll send you through the process of what is required for you to get access to that area. Generally, it's aircraft type you're operating, your expectations, what you're intending to do, how often you need to do it. Whatever they ask, you sort of come back to them with that information and they'll give you a response. A lot of times you will get the approval and it will be pending them giving you a phone call to cancel the approval at any minute. So they will need a contact number. They'll give you that approval in the airspace, but they can recall that at any moment. So they expect that you'll be able to cancel your operation, that being the case. So we've worked with Defence a lot in the past. They're very good to get along with, give them the necessary information, and they're usually a good crew to work with for a good outcome to operate within that restricted area. There are some areas you just can't get access to, unfortunately. If you're in vicinity of military areas, or facilities, there are some areas that you just will not get approval. Now, this is identified in the back of the IRSA as well, in the that special use area. And I'll go through that in a moment. So danger areas. So what is a danger area? So danger areas, particularly those associated with military activity, are often activated and their status is communicated via NOTAM. So you don't need a specific approval to operate in a danger area. Most of them are active 24 hours and they're used for civilian or military operations. Military danger areas may receive advisory through the NOTAM system. If they are going to operate in it, they may let you know or broadcast in NOTAM that there is upcoming operations. When you're operating in a danger area, you need to be more vigilant, as crewed aviation are working in that area and they have approval to operate from surface up to a given height. Now, there's all types of operations you'll get in there. You may have fast military jets at low level cruising along at 200 feet. They're going to blast straight through your area, even if you're operating up to 400 feet, because this is their training ground. You may have aircraft that fly over your head at 4,000 feet, and then all of a sudden you turn around, they're coming at you and they're 500 feet behind you because they're undergoing a simulated engine failure. Using that particular danger area to be able to do these type of things. So you just need to be more vigilant. As I said, military, you just need to be a little bit more vigilant in that they use those areas and their jets move very fast. So I recommend if you're going to operate in a danger area associated with a military facility, contact them via the same contact details as you might find in URSA. Just let them know your intentions. They might be able to note down not to operate their fleet of F-35s in that area where you're planning to operate for a significant time. So the danger area, things you can expect in danger areas aren't limited to just flight training. It may also be blasting, it may be parachute operations, it might be a rifle range, transit lanes for crew traffic, science research, military bases and aerobatics. So ultimately the VHF radio is a good line of defense to have in those areas. However, you may not hear a radio call. You know, if you've got military jets flying through it, supersonic speeds, they're not going to be making radio calls to what they're doing. Likewise with GA aviation, you know, we're not making radio calls when we're about to do a forced landing. It's all just given that we're in a danger area, it's open airspace and we're keeping a lookout. So that's also the best thing for you to do if you're operating in a danger area. Just keep a good lookout, you know, have a listen and see what you can hear, if you can hear any aircraft, and take a good, have a good situational awareness. So in the back of that URSA is that SUA section. So you've got some information there, and here's a little breakdown of it. So you've got a breakdown for your restricted, your military operating areas, and your danger areas, and it's just the information you can see. So for example, for the restricted, you've got the ident for the area. Now the RA2, that's the status. So at the top of that area, you'll see a status table that tells you what you can expect in the RA area. So it basically says here, RA1 pilots may flight plan through the RA under normal circumstances and expect a clearance. Okay. RA2 pilots must not flight plan through the area, but they may be able to get a clearance through. And lastly, RA3, don't flight plan through there. It's unlikely you'll get a clearance. Now, this is obviously based more on crewed aviation. However, it may play its part to RPAS. And RA3, don't plan a whole operation there till you're assured that you can actually get approval to operate in it, because it may just be airspace that it is not something you can use. So that's all in the back of the URSA as well. So just lastly, in summary, restricted areas and military operating areas are treated the same in Australia. Approval is required before entering an active airspace. So if it's not active, you can enter it. Sometimes that restricted area may actually be higher than ground level. So if you can operate in an area that's below an active restricted area that may start at 3,000 feet above your head. So it may not be an issue for you. So just remember that. Approval may also be obtained with operating within 3 nautical miles of a military aerodrome using the same process. So you may be able to contact the same point of contact there at the military location and get approval to operate within 3 nautical miles, because it may be part of the restricted area as well. CASA no longer manages airspace associated with military facilities as per instrument 2323. So you can go directly to the military now and say, can I operate my drone within 3 nautical miles of your airport? It is a restricted area, and they will go through the motions of what is required for you to be able to do so. URSA provides comprehensive details for special use airspace, including contact information for the relevant airspace manager. So basically work process is find the area, go to the back of the URSA, find out who to contact them, follow the procedures that they need you to do to get the okay to operate in that area. Danger areas don't usually require formal approval. However, remote pilots must remain vigilant due to a high potential for rapidly changing conditions in that airspace. And monitoring VHF radio in danger areas is recommended, although it is only one line of defence. So without further ado, that is me. I have completed my danger area and SUA airspace. So
thank you very much, Jared. So I will invite Sasha to take over and dive into his presentation. We do have quite a few questions for him. Particularly, we want to find out what a UTM, FIMS, and USS are, what government mandates and AAA trials already exist, what does the UTM mean for operators in the next 1 to 3 years, what does the long-term view for RPA integration into airspace look like? And lastly, how we can all stay engaged through various forums, consultations, and working groups. So I'll hand it over to you now, Sasha, if you could take us through that.
Yeah, awesome. Thank you. That is quite a lot of questions, so I'll do my best to cover that in plain English speak as well. So look, I just wanted to say firstly, thank you so much to Jackie and the Hopper team for the opportunity to come here today and talk to you a little bit about the work that we're doing at Airservices in this space. I think this sort of stuff is really important and really, really valuable to come together and sort of have these sorts of conversations. As an organisation, it really gives us an understanding and a feel for what good looks like for you guys as well, and that's a commitment that we've got to keep checking in on and to keep working towards with you. So as I said, it's quite a lot of questions that have sort of come my way today, but happy to sort of do my best to try and answer them. So I guess by way of introduction, my name is Sasha and I'm in the role of Director of UTM Enablement here at Airservices Australia. So I'm conscious that, UTM might be a term that many people haven't heard of before, or maybe you have heard of it and you don't know what it means. So again, really happy to sort of come in today and talk to you a little bit more about what it means and some of what I think is great work that we're doing at Airservices to develop the UTM ecosystem. So I think one of the first questions that's pointed my way is sort of what is UTM, what is FIMS, and what is a USS? So look, I guess starting off with what is UTM, the Australian government, together with the emerging aviation tech industry, is building this new ecosystem that we're calling the UTM ecosystem. And UTM stands for Uncrewed Traffic Management. And the whole intention of all of this work is to be able to safely integrate drones and other crewed and uncrewed aircraft into Australia's airspace. So some of the work that we've been doing at Airservices really is starting to tell us and show us that this is an incredibly fast growing sector of the aviation industry. Some of the forecasting we've done sort of says that drone activity is going to grow from 1.5 million flights a year today to something like 60 million flights a year in the next 20 years. That's absolutely huge, and it's the fastest growing component and sector of the aviation industry. What that means is that we need a modern system to manage all of that air traffic, and that's where this concept of UTM comes in. So UTM is in essence a digital ecosystem that's designed to coordinate and manage uncrewed aircraft operations. And it's sort of as simple as that. So I guess much like road traffic management, there's many different components that sit as part of that traffic management ecosystem. And you'll sort of see that wheel there on the screen, which was in the latest UTM action plan that was set by the department. But it sort of starts to paint the picture of all of the different facets of UTM that need to come together. So regs, infrastructure, standards, technology, roles, responsibilities, rules and services, they're all really important parts of enabling this new digital ecosystem. So I guess to answer the question of why do we need UTM, without UTM, that expected volume and the complexity that we're expecting to see in airspace in future could start to pose real safety risks and limit the potential of this great industry to actually grow. And that's not something that we want to see happen. So UTM and our work in this ecosystem should ensure that drones are safe and efficient to operate, whilst also enabling growth and innovation in this space as well. And finally, something that we're hyper conscious about at Airservices is that to deliver all of this, it needs to be delivered in an economical way for everyone as well. So I guess in a nutshell, that's sort of what UTM is. If I kind of just then sort of step through the next layers of this, so we've spoken about what the UTM ecosystem is, what's this FIMS thing that we keep talking about as Airservices, and what's a USS? I guess the important thing to keep in mind is that to successfully integrate all of these drones that we're talking about into Australia's airspace, we actually need a few different key components to come together in perfect harmony, so to speak. So the first component that needs to come together is FIMS, or the Flight Information Management System, and Airservices Australia is actually delivering this on behalf of the Australian government. FIMS is to become the cornerstone of the future UTM ecosystem. So what is FIMS? Think of it as a bit of a central digital gateway. It's going to facilitate that exchange of information between all of the different operators and participants in that ecosystem. And it's going to provide operational oversight and essentially allow the coordination of drone operations right across Australia. So, and that's a system that, as I mentioned, Airservices is delivering in collaboration with industry and government. The other key component that needs to come together is the USS, or the UAS service supplier. Now, these are essentially industry-led third-party providers that are going to be the ones that are connecting into FIMS and delivering services to drone users. So how does this ecosystem, I guess, come together in practice? So the reality is that, as I mentioned, we're developing the flight information management system, but we're working really, really closely with the first 3 UAS service suppliers, which are the ones that you see there on screen, to ensure that by the time this launches in a number of months, we're ready for the introduction of these services to operators, to you guys, to industry. So whilst the first 3 USS, which are the ones you see on screen, are the first ones to connect into FIMS, we're really committed to working with industry really closely next year to essentially grow that from those 3 to a much broader group of people. And our intention is to try and do that sort of as quickly and sustainably as we can. So working together is really, really important to be able to provide these services out to industry. FIMS alone doesn't actually provide them directly to an operator. We actually need industry to facilitate this and work with us. So in terms of the types of services that you'll sort of see FIMS enable and provide out to operators, I just want to stress that FIMS is going to be delivered in phases. It's not going to be an overnight, here it is, everything is launching. It will actually be delivered in phases over a number of years. But the first sort of suite of services, if you like, is access to automated airspace authorizations across all 28 civil controlled aerodromes. That'll be near instant, and it'll reduce paperwork and wait times for industry, which we're really excited about. Airspace data that's timely and relevant to the RPAS community, and then the ability to input flight plans and to actually be coordinated from other known RPAS in the same vicinity are sort of is a summary of the first suite of services and capabilities that will come online. I'll talk a little bit more about each of these in just a sec, but I've just sort of wanted to paint this picture for you of how these 3 components actually come together to bring this to life. So why does FIMS actually matter? I guess kind of as I was just talking about earlier, Australia is on the brink of this new major shift in aviation. There's going to be a huge surge in activity and demand that we're expecting to see in the uncrewed space in particular. And so Australia needs a modern digital solution to be able to manage all of this. And that solution, we believe, is FIMS. But how does FIMS actually work? So it's designed specifically for uncrewed operations. And it acts in the background, like you sort of saw on that diagram just earlier. It's a back-end facilitator that's enabled through third-party UAS service suppliers. It allows operators to access its services through those USS. And the experience of actually transacting through all of this is really quite simple. And I think this diagram sort of helps explain that in 5 easy steps. So if you sort of look at step 1 in terms of what the experience would look like, step 1 is that the operator, such as yourself, might connect to a verified USS app. It'll be the first 3 that I mentioned on screen before to start with, but our intention is to grow that. The app would then connect into the world of FIMS as step 2. Step 3 is then where FIMS comes in to facilitate that exchange of information and the communication between all of these different UTM participants. Step 4 is that the information that FIMS sort of aggregates and deciphers gets spat out back to the USS. And then the final step there is that as the operator, that information is available to you at your fingertips in a really easy to use digital and automated way through your USS application. And you can then safely initiate your flight or potentially submit a new flight plan. So I know that this might kind of sound a little complex, but in reality, it really is sort of a really cohesive, easy to follow process, which we're really excited about. The next question was, well, what does UTM mean in the next 1 to 3 years? So what does this actually mean for you? Well, I guess, like I said, FIMS is the backbone of the UTM ecosystem, and it's going to be delivered in phases. So initially, the main benefits for you will be access to faster, near instant authorizations in more airspace. So obviously, there are trials that are out there at the moment that allow AAA capability for 10 aerodromes. The beautiful thing with FIMS is that from its launch, this will be available across all 28 civil control aerodromes. Outside of the trial that exists, the alternative today is obviously a really manual and potentially costly process. So we're really excited to be able to help reduce paperwork and any administrative burden to be able to allow you guys to take flights sooner in a more economical way. The second thing is probably to keep in mind is that it's a system that's actually built for uncrewed operations specifically. It's not something that's been sort of adjusted or adapted. It is specifically built with uncrewed operations in mind. It offers reliable and timely airspace information that's relevant to RPAS, so no-fly zones, nose hams, and other airspace data that you might get from airservices.data today will all be available through FIMS. It will enable better airspace awareness with the ability to input your flight plans and be coordinated from other known RPAS activity that's operating in the same vicinity as yourself. And I think the great thing with this is that it's all digital and it's all automated and it's all available in one place and at your fingertips. So that's sort of a summary of what this means in the immediate term. Like I sort of said, in the future, our intention is to work really closely across government and with industry so that we continue to expand FIMS and where it's available and the capabilities and services that are available. But what will never change is its ability to offer you all of this in an automated digital way at your fingertips. And that's what really I think is the revolutionary component of this. So what government mandates and trials exist today? So I sort of mentioned, I spoke a little bit about that automated airspace authorizations capability that will be available through FIMS for all 28 aerodromes. Look, government policy is really clear and it highlights sort of the foundational role that FIMS plays in UTM. You may have seen a great document that was put together last year by government, the aviation white paper. Kudos to anyone that's read it end to end. It's a big document. And it sort of outlines the real important role that Airservices plays in delivering FIMS and delivering UTM. And I think the important thing that you sort of gauge from reading that document is that this is going to be delivered in a phased and iterative way. The paper is really clear about the need for innovation in this space to continue to evolve and grow because the demands of this growing sector are only going to continue to do just that. And the intention is for FIMS to be able to respond. So whilst those initial capabilities that I just spoke about are expected in the next couple of months, they're going to be a baseline and we're going to be working to develop a really clear pathway for what do future enhancements look like to be able to support all of that growth. So in terms of government mandates and policy, it's really clear about the role that FIMS will play in future to be able to support that. Onto the point about the trials. So since 2021, Airservices and CASA have been trialing the automated airspace authorization trial for commercial drone operations within 3 nautical miles of selected control aerodromes via a drone safety app or a DSA. I believe that trial is now for 10 civil controlled aerodromes. So pleased to confirm that that trial and all the work that we've been doing with CASA has gone really, really well. There's been some fantastic insights that have been generated about the needs that operators have and what works and what doesn't work. And so the trial will come to an end and that capability will be delivered exclusively through FIMS and USS in future. So FIMS will essentially become the home of automated airspace authorizations for all 28 civil controlled aerodromes. That's again not going to be something that happens overnight. CASA and Airservices are working through a transition plan for all of those existing DSAs that offer AAA capability to essentially give them the opportunity to connect into FIMS over a period of the next 12 months. I know that we've obviously, we're launching FIMS with just the 3 USS that you've seen on the earlier screen. We're really committed to working with existing DSAs, especially those that offer AAA capability, to give them an exclusive opportunity to be able to onboard onto FIMS next calendar year. And work with us to continue to develop this capability out to market. That's absolutely recognition of the valuable contribution that those DSAs are making to uncrewed operations today. So what does the long-term view for RPAS integration into airspace look like? Look, that's a big loaded question, and try to kind of simplify this on a little bit of an image or a little bit of a roadmap for you. We're firmly focused on enabling a mature, integrated airspace where all airspace users, crewed and uncrewed, can operate safely and efficiently together. So the development of UTM and FIMS represent really critical steps towards this future. Our view is that over time, RPAS will transition from being managed separately to being fully integrated into both controlled and uncontrolled airspace. Strategic investment in UTM and digital air traffic services like the FIMS are going to enable us to actually safely manage all of that anticipated increased operation, but also the increased complexity that will come from all of that growth as well. Obviously, maintaining the high standards of safety and efficiency that Australians are expecting from our aviation system is the key critical component of all of this. So long-term integration, our absolute objective here is to be able to unlock more advanced capabilities. So be it large-scale logistics, beyond visual line of sight operations, tactical deconfliction, urban air mobility, AAM and air taxis, they're all things that we are trying to think about and pave the way and pathway towards as the ANSP. Because at the end, this will all deliver significant economic and social benefits right across the country. So look, I know that this is a bit of a, it's an attempt to try and simplify something that's really quite complex. And we absolutely recognize that there's still a lot of work that needs to be done to bring this to life. But we're really taking the steps that we can today through things like UTM and FIMS to really be able to pave the way towards this sort of future in Australia. I think the final question that I had, and guys, correct me if I'm wrong if I've missed anything, but in essence, it's how to stay engaged. And I know that today, it's a great opportunity for, at least I feel it is for me, to come in and talk to you guys for 10 minutes about the work that we're doing. But by no means is this sort of the end of the conversation. My role exists and has been set up as a way to sort of work across government and industry to sort of together build this UTM ecosystem. So if you're keen to stay engaged, I'd absolutely recommend reaching out to myself. If you've got any questions, I'm happy to sort of meet people and answer any questions that I can. Sometimes I won't have an answer, but we can certainly try. Absolutely feel free to visit our website. We've got a dedicated page on UTM, which is Airservices Australia /UTM. You can contact us directly as well, as in the team at Uncrewed Services at airservicesaustralia.com. We also have a number of working groups, such as the USAN and the AAA working group. Some of you may be a part of those working groups today. Others may not, but may want to be involved. So please go to our website and find the links to how you can get involved. But like I said, always happy to sort of have a conversation. So please feel free to reach out if there's anything that's on your mind or you want to talk about.
Thank you very much, Sasha. That was very good information for us. I am going to hand over to Chris again. So Chris, I've got a couple questions for you around operating within controlled airspace. So firstly, what approvals are required for flights in controlled airspace and no-fly zones? And also, how do we go about seeking those approvals? So I'll hand that over to you, Chris.
Thanks, guys. Thanks, Sasha. So I'll share my screen again. So as the guys mentioned, the questions around what approvals are required for operating in controlled airspace, and it's important to distinguish where that controlled airspace, approval starts. So what we're actually referring to is the area 3 nautical miles from a controlled aerodrome. Flight in controlled airspace is generally, permitted up to 400 feet outside of that area. And as Sasha mentioned, there's sort of currently 3 ways that you can go about getting those approvals, or currently 2. First being a manual process where you submit the application form to CASA and ask for your approval for the area that you want to operate. And then the second way of getting a approval, of course, is the AAA, or the auto airspace authorization trial that's been running for some time with CASA, of which we were one of the first 3 to integrate with. And so that takes that 28-day approval down to instant for those 10 airports that Sasha mentioned. So what I'll do is I'll show you a little bit about how that works, and there's some kind of we get questions about this commonly, about why you can't get an approval, or what these areas mean. So at the moment, what we're looking at is Adelaide Airport. Again, you've got this kind of funky shaped, area of hexagons. That's the 3 nautical mile boundary, and inside that's broken down into grid cells, and each of those grid cells define an altitude at which you could fly. So it's important to note that area, that sort of honeycombed area off the 2 runways, is an Airservices data set. So they supply that with the rules around operating in each of those squares or rectangles. Overlaid on that, you've also still got the CASA requirements around flying in the approach and departure areas of an aerodrome. And that is the one that will override it. So the grid cell may tell you that you can fly, but the fact that you're in that approach and departure area will actually reject this instant approval. So if I start to zoom in a little bit into our job area, we're actually operating, say, for example, in this cell. When I click on it, it'll actually tell me the maximum height. And the way we've structured this, another important aspect to this is that only the chief remote pilot is allowed to submit this authorization, and that's a CASA stipulated requirement, strict requirement. But that can be troublesome at the planning stage for a pilot that's just putting in a plan to send to their chief remote pilot. So we display these grid cells, but the pilot can't really do anything with them. So the idea with that is you can plan a good job that will pass to then give to your chief remote pilot in the approval stage to actually go and seek that authorization. And so what you're looking at now is how you would actually go about doing that. But again, you've got an Airservices area, and then you've got a CASA area. The CASA area being the approach and departure displays will override whatever one of these grid cells say. So I'll go to a job that's sort of at chief remote pilot stage now to just show you that process. So this is the same process that you would have gone through many times if you're an AVCRM user, creating a JSA and a job with the added area of this authorization tab for those that are on the trial. And when we get to that point, the chief remote pilot now has this ability to add in the mandatory requirements to describe what the flight is and who's going to be flying it. And then it allows you to perform a data check. And what we're doing here is just assessing all of the rules relating to your job and confirming that they are all indeed correct prior to submitting for the approval. So for example, if your REOC was out of date, the registration was out of date, the job area fell in a place that was not allowed, all of those things will come up here prior to you actually submitting the approval. And assuming that you don't get anything red, then you can submit that, confirm it, and it'll go away to the AAA system and fetch that approval. And from there, you can you'll get your approval number.
While we wait for Chris to rejoin us, what I might actually do is just move forward with my section talking about the advanced airspace operations, and then I'll let Chris pick back up once he's back in the session. All right, so I'm just going to talk briefly about some advanced airspace operations and how that may factor into your planning and approval process. The first thing I want to start off, though, is just a bit of context around advanced airspace operations. So the RPA zone or area that we commonly say we operate up to 400 feet AGL in those standard operating conditions, to put that into context, is only about 1/3 of the height of the Q1 tower. So in overall airspace, it's a relatively small section of airspace that you can be operating in. And it's also not solely just for RPA usage. If you've ever been around the Q1 tower on the Gold Coast, you will notice there is a lot of low flying activity for people who are enjoying the scenery or taking helicopter tours, that kind of thing. So it's not just an exclusive RPA zone either. Now, in Australia, you can get operations above 400 feet under a variety of approvals. This can look like something like an atypical airspace approval or a specific area approval just for above 400 feet. And then you can also include operations above 400 feet as part of a broader approval in something like a BVLOS safety case or a SORA case for more complex operations. Another consideration that we have is that denser airspace areas like Class C and D airspace or MOAs will require specific approvals and applications to operate within them. And there's also the tools that Jared mentioned earlier on when you're doing your planning to make sure you get a really clear picture of the airspace and what you need to do. So I'm going to talk quite a bit about operations above 400 feet, which is something we get asked a lot of. Most common question I get is just a map of an area from a client saying, can I fly above 400 feet to XYZ height here? And there's 3 different ways you can approach an above 400 foot approval. So the first kind is in atypical airspace, which is broadly defined as within 100 feet vertically and 100 meters horizontally of an obstacle. This can be something like a wind farm tower or a building itself or a bridge, something along those lines, where you'll be above 400 feet, but because you're in an area where aircraft don't typically operate due to the risk of collision with said obstacle, it's considered to be a relatively low risk operation. You will still require a NOTAM. It's a common theme. Anytime you have any type of area approval, you require a NOTAM to be active to undertake it. And you may or may not require a VHF radio to monitor for other airspace users, which will be dependent on where you're operating and the class of airspace around your atypical airspace. Now, you may be required as part of your procedures as well to have a visual guide on the ground to make sure that as a remote pilot, you can have a good indication of where your RPA is and stay within that atypical airspace. When you move up to the next level, which is an area approval, so you're no longer associated with that protected airspace around an object, you may be required to consider additional things like geofencing, definitively having a VHF radio on board and being able to make those broadcasts as well. You may also be required to have ADS-B in to maintain awareness of that airspace, depending on how dense or complex it is. And when you think about flying 400 feet, or to put it into meterage, which is 120 meters, if you're going 400 meters up in the air and you move 100 meters away from yourself, the distance from you, just line of sight to that drone, is increasing at a higher rate because you're moving further away with every lateral meter. So you may find that your operation is only conductible if you can do it under something like extended visual line of sight through the use of observers to maintain awareness of the airspace and ground risk. So it may not be a VLOS operation depending on how high you fly. And you may also require a stakeholder engagement plan. I will talk briefly about something that was mentioned earlier with danger areas, is that a danger area may indicate a denser airspace to you where you may have additional risks. But for the purpose of finding stakeholders, they're kind of a gold mine because you have this formally acknowledged area where a specific activity takes place. So if you need to find stakeholders as part of your CASA approval to fly above 400 feet, a danger area actually makes it really easy to find them. Now, you can also operate above 400 feet while operating beyond visual line of sight. This is becoming really common, particularly in the powered lift space. So again, you'll be operating within a pre-approved area. You will almost always be required to have some kind of geofence when operating beyond visual line of sight. You will require your NOTAM and your VHF radio, and you may require ADS-B in. And if you're operating in a particularly dense environment, or you need to give an air traffic manager awareness of your location, you may even be required to operate ADS-B out. You will definitely require stakeholder engagement to operate beyond visual line of sight, which will involve identifying the other airspace users you may encounter. And as part of your overall risk assessment, you will actually have a set target percentage of aircraft that you need to be able to identify based on your overall risk level. So for Sale 2 operations, which are very common in Australia, you must be able to identify 50% of the aircraft. And as part of your flight assessment, you'll have to show CASA how, through the combination of all of these tools, ADS-BN, aviation radio, stakeholder engagement, NOTAMs, your presence in space, how you're able to identify that target, which is part of your tactical performance mitigation requirements. So things to be aware of when you're preparing your above 400 foot application is your class of airspace that you're operating in, which will give you your first indication of how dense it will be. I will say never assume that G-class airspace is relatively unbusy airspace. You want to be keeping an eye out for things that might not come through on a chart. Advisory circulars, Facebook groups of local pilots, for instance, is a really good one that we love. Another thing to be aware of is flight paths. So Jared's gone through all of the tools where you can access them, but you really do want to be considering VFR routes, as well as the approach and departure paths and procedures that exist. Quite often when we're planning a BVLOS mission, we will find that a missed approach or an NDP does come in through our airspace, which can indicate to you that you're going to have a certain density of aircraft in that area. You want to consider your proximity to aerodromes and how the aircraft around them are going to be interacting with that aerodrome, and what NOTAMs or AVCRMs may have been historically active in the area, which can give you an indication of how often people are flying there and what kind of activities they're conducting. Another really good one to look out for if you're planning to operate above 400 foot in an area is there another RPA NOTAM in that area that's been active from time to time, which can give you some indication of what's accomplishable in the area. Now, if you're looking for some additional tools there, AVCRM and the Aeronautical Information Package are really great for finding this information. If you'd like to put a direct overlay of your operational area onto some aviation maps, SoraMate is another awesome tool that will allow you to do so. Lastly, I will talk about ADS-Bs and RPAs and their interactions. So at the moment, ADS-B is currently adopted by about 16% of crewed aircraft, and it's widely available as an ADS-B in on modern aircraft for RPAs. So a lot of the recent DJI products in the last 3 years have DJI AirSense, which will enable you to detect other aircraft that are equipped with ADS-B out. ADS-B out itself, though, is not widely a standard tool for RPAs, and it's usually configured post-purchase, so it's not necessarily something that's included on your system. It may be more commonly included as a part of the GCS of your system, as opposed to the aircraft itself. Now, when we talk about using ADS-B in RPA operations, it's very commonly a part of that TMPR section of SORA safety cases to identify a certain percentage of aircraft, and it can really help to raise your situational awareness, regardless of if you're just doing a standard operating conditions operation all the way through to complex above 400 feet beyond visual line of sight flying. And we are going to potentially be looking at cases in the future where ADS-B out might become a requirement, which relates to that controlled airspace piece. Something that we've worked on quite extensively is operations within 3 nautical miles of a controlled aerodrome. And a big issue is how is the airspace manager going to identify where you are to deconflict you from crewed aircraft? And ADS-B out is one of those proposed solutions that will enable ATC to see exactly where you are and give guidance and provide separation services appropriately. So ADS-B in and out will obviously play a critical role in upcoming UTM projects as well, which will enable some real-time mitigation. And we did have a question earlier about, how are UTMs going to prioritize who can access airspace at certain times. I'll obviously ask Sasha to talk more on that, but any kind of real-time deconfliction, similar to what you see in crewed aircraft, is going to rely at least partially on the ADS-B system. As Jackie was saying, we will provide more information through Hover and, of course, through AVCRM on their website as the FIMS continues to roll out. And you can find more information about using the AVCRM tool on AVCRM's website as well. Before we jump into questions, just quickly for anyone who is jumping off soon, I will also mention that we do have an up-and-coming webinar that will be released for registration soon. And that will be the safety management systems for uncrewed operations. You can scan this QR code here to get yourselves registered for that one. So thank you again for everyone who has attended. We're going to jump into our Q&A section now. We do have quite a few questions to get through. So I'll just invite Sasha and Jared as well to just answer as you guys see fit. So let's go ahead and have a look at these questions. Yeah, Jared is also a very well-versed AVCRM user. So we'll just kind of start from the bottom up. UAS, EBLOS and BVLOS operations, why are they not using managed altitude and existing aviation units? So that's a question from Neil. So I will jump in and just talk a little bit about this first, if it's okay with you guys, is that when we prepare a BVLOS application to CASA, we do actually use the crewed conventions in preparing that. We talk in feet, we let them know what our AGL equivalent to AMSL will be where it's relevant, particularly above any operations over 500 feet. So while it is a convention that's popular to use meters and AGL as opposed to feet and AMSL, mostly due to the commercial presence of drones where it's probably someone's first interaction with aviation as a pilot to buy a drone off the shelf and fly it. And, you know, meters and AGL is easy for them to understand. When we talk about commercial operations in complicated areas, we are typically adapting to the crewed systems as well as a part of that. And would you say that's your experience?
Oh, I'd agree. And look, normally people operating these more advanced operations also have more advanced aircraft. And we're seeing more and more of those aircraft now allowing AMSL data to be presented. You know, there's a difference between a Mavic 3 Pro and a Mavic 3 Enterprise in that Mavic 3 Pro doesn't have AMSL. You go up one level and AMSL is available. So it'll become more standard, I think, as drones roll out. It'll probably become a standard to even consumer model drones in the very near future. I think it'll just be a standard. And it's up to the user then to just choose what setting they want to operate under.
Yeah, and something that I've actually seen on a recent BVLOS project that was from our last webinar talked about by Andrew Tridgell is with certain softwares like ArduPilot, you can actually customize a display that will show you your AGL level based on geographic location and satellite data and your AMSL based on your input from air pressure. So particularly when operations get very advanced, very long range, people are taking the necessary hardware and operational steps to kind of match crewed aircraft. The next question we have is around NOTAMs from Evan. Why not have NOTAMs and weather in plain English in the first place? Jared, your thoughts?
I don't know the exact reason for that one. I know, look, NOTAMs and weather and the coding that they're in have been around since the 70s, probably the 60s. So I would assume that initially it was brought out in this type of coding to be a worldwide standard through ICAO and known worldwide to what it is. And we just haven't adapted. Sasha might be able to let us know more, being Airservices. It might be out of his scope, but Sasha, have you got any say on why NOTAM and weather is still in the standard format for aviation as opposed to plain English?
I think I would be making it up. Unfortunately, it's outside my scope to give you guys an actual concrete technical answer. Apologies.
Yeah, it is one of those things. Look at it. It's one of those things, I guess, as I've been a crewed aviation person for 30 years, it's just been drummed into you. To me, it's just a standard. But yes, I can see how it's a big issue. That's why there's a lot of decoding tools out there. Definitely use them. You know, if you're not in an exam situation like I have with my BVLOS Octa people, use them. You know, you can grab that information, you can drop it into the software. It'll tell you in plain English. Some software even has it built in. If you go into Oz Runways, you can click on the plain English button and it shows everything in plain English. So yeah, it might be a fight to have with Airservices, that one. Speak to the NOTAM department, maybe.
We can take that on notice and let them know. How about that?
There we go. Sasha's on side.
Thanks, Sasha. So our next question again from Neil is about how EVLOS and BVLOS UAS ensure separation with manned and unmanned aircraft in Class G airspace, keeping in mind that a lot of manned VFR aircraft are not ADS-B in or out equipped. So in a small answer to that, for EVLOS operations, you do have a requirement to use a trained observer to maintain situational awareness of the air and ground risk. And thousands probably of EVLOS operations have occurred, both under CASA supervision as part of flight assessments and now out in the world by operators, with little to no interaction to report of note. So the EVLOS procedures are working as intended. BVLOS is a more complicated question where we use things like stakeholder engagement, VHF radio, prior notification from NOTAMs, and yes, the limited ADS-B data we have to create that separation. Where, as I mentioned earlier, it'll probably be tested is as we move from uncontrolled airspaces into controlled airspaces, that's where the potential for interaction will be higher, and some of those BVLOS methodologies will be tested. But that's kind of the thing that we're working on with CASA now, and is kind of a next step to us in terms of working out exactly how we will mitigate on those risks. Anything to add on that one as a BVLOS?
I'm happy with that.
Happy? Brilliant. Stephen, so features when you click on Airspace and AVCRM, EVLOS note only. So this relates to the MOS 101.511 2C note. So any part of the operation conducted within 3 nautical miles of the movement area of an aerodrome, including an aerodrome that is a HLS, the height of the RPA must be referenced to the aerodrome or HLS elevation. Is this applied to all operations within 3 nautical miles?
Sorry.
Yeah, it is one that is deep in the complexity of written legislation.
Yeah.
So it's something that I'd be a bit hesitant to answer without having the MOS next to me to dive into. In general, though, I think we'd both agree, excellent safety practices, even if it is not a requirement, if you are operating in vicinity of an aerodrome and you're attempting to communicate with aviators who are using that aerodrome, it's probably best to talk in their language and give them your position and altitude relative to something that they're going to understand. So something that I quite often recommend to people is if there's no aerodromes around and you're trying to reference what you're doing, reference a VFR reporting point, because the people who are navigating VFR through that area are going to know exactly what you're talking about.
Yeah, I agree. The other confusion at an airport is too, you might read circuit procedures. Circuit procedures are based on AGL. So when you go into a circuit at an airport, you're doing it at about 1,000 feet AGL. Until you get into the circuit area, though, you're basically using AMSL. So there is a little bit of a confusion there. But yeah, I agree with Dylan. Try and use something that you think will make it very easy for you both to understand the situation.
Yep. Next question is, do drone pilots still need to listen to or use an airband radio when flying in areas that aren't controlled or uncontrolled airspace?
Well, look, there's no legal requirement to use a radio operating VLOS. The whole idea is you are clearing ground and air risk using your eyes, and that's why you should be able to see the drone, I may add. You're clearing that airspace to understand that it's safe. So we use a radio. Look, it's good airmanship to have a radio. At least you can get a situational awareness of what's happening around you. If you're monitoring that frequency, you might know that there's a plane 10 miles away ready to fly towards an aerodrome that may be near you. So it gives you that little bit of situational awareness. No legal requirement to do it. Controlled airspace, you don't even need a radio operating up to 400 feet as long as your drone is below 2 kilos. If your drone is above 2 kilos in controlled airspace, you now need to have an AROC and a radio and be monitoring the relative frequency. Anything under 2 kilos, you can operate in controlled airspace without a radio, and it's still standard VLOS rules. So.
Yeah. And I will just add that if your procedures in your operator's manual or a specific approval that you've received do say that you need to do the radio, that approval and procedures will come first over the MOS standards. So it'll be the more restrictive requirement typically. Our next question is from Stephen, and this one's for you, Sasha. It's asking about USS service providers, fee for service. How is this going to work for not-for-profit and educational institutions?
For not-for-profit and educational institutions, look, I mean, ultimately, Airservices has obviously the free resources that it provides on its website to sort of enable flight planning. Ultimately, the way that a USS conducts its business is completely up to them. They're set up as a commercial entity with sort of a need to generate a return on investment. We will be working with CASA on still what the entire ecosystem looks like, and even existing DSA applications and what their place in the ecosystem looks like. So it might not be that a USS is the answer for someone like that. But I mean, safety is of the utmost priority, and we'll continue to do what we can to make sure that we're promoting those principles. So I think that's sort of the short of it.
Brilliant. And we also have another question from Blake, which is the objective that FIMS will inform you of other operations in the area? If there are multiple UAS in the area, is there going to be a method of determining priority? And they can foresee things being very important for issues like drone delivery and BB loss as that increases in popularity.
Yes, the answer is yes. So if you are submitting your, in the early stages of the ecosystem where obviously participation is voluntary, outside of that 3 nautical mile area, obviously, you will know and be coordinated from any other operations in the same vicinity that you're proposing to operate in. There will be a series of prioritization rules that will come into play to, in essence, determine who has right of way and how it works. FIMS itself is not the creator of the rules or the decision maker. It's facilitating the digital sort of enablement of that solution. There's a variety of factors that will come into play, including policy and regulatory settings, airspace class rules, constraints that that exist intent to operate. There's a whole series of items that will come into the equation. But FIMS will simply be the one that enables it digitally rather than making the decision itself. But the simple answer is yes and yes.
Cool. Thank you very much, Sasha. And thank you again for joining us today. And thank you to Chris, who'll probably see this part on the recording. We are going to wrap it up here today as opposed to an unrecorded question section because we want to be conscious of people's time. It was already a longer session and we are right at the end. So it feels good to end right on time for a first. So thank you everyone for coming. Please remember to register to our next CRP professional development session, which will be around SMS, something we get a lot of questions about as well. And thank you again to our guests. Remember, you can reach out to us at hoveruav.com.au and you can reach out to our guests as well should you have any further questions or anything else you want to discuss, particularly in the airspace space. So thank you everyone. Thank you, Jared. Thank you, Sasha.
Thanks, guys. Thank you.
Thanks, mate. See ya.
Thanks everyone, and we'll see you in the next one.